Welcome to the video lecture on the course of Amp and Linear Integrated Circuit. In this session, we will be discussing the topic of DC voltage regulators. So first of all, we should know where we are going to use these DC voltage regulators. As the technology is improving, the electronics devices or electronic circuits are going on improving, and these electronic circuits mainly operates on DC power supply. And for these electronic circuits or the semiconductor devices, what we call, it requires a constant DC power supply. Because of this part, the DC voltage regulators part is into account to keep the DC power supply into a constant value. And especially we will be discussing the basics of this DC voltage regulators in this particular session. So first of all, what is a DC voltage regulator? A DC voltage regulator is a device which maintains the output voltage of an ordinary power supply. So here power supply is nothing but it is a DC power supply constant irrespective of load variation or changes in the input AC voltage. Whether there are variations, this device, the regulator, DC voltage regulator, maintains the voltage of the power supply a constant value, and for that reason we call it as a DC voltage regulator. Taking the example, a stabilizer which we normally use in our household applications, it is a voltage regulator. Stabilizer is nothing but it stabilizes the voltage. It is a voltage regulator, what we call. Electronic circuits using tubes or transistors require a source of DC power. Now we can obtain this DC power from batteries, and normally these batteries are not preferred, mainly because they are costly and they require frequent replacement. So what we do is we obtain the DC power from the rectifier filter system. DC power for electronic circuits is most conveniently obtained from commercial AC lines. So we get an AC power supply easily, that is a 230 volt 50 hertz AC supply we get, and we convert it using a rectifier and a filter system into a DC power supply. So seeing the block diagram of the regulated power supply. So this is the total block diagram of a regulated power supply. What we use instead of batteries, we use a rectifier filter system. So normally we obtain a power 230 volts single phase 50 hertz power. So by it will be a sinusoidal voltage what we get, and that sinusoidal voltage is stepped down using a transformer. We use a transformer at that particular part so that high voltage is reduced to a smaller voltage. So we get a step down voltage using a transformer, and then we use a rectifier circuit. A rectifier circuit is used which converts AC voltage into a DC voltage. We get a rectified output voltage at this part, and as we see at this particular point, the rectifier voltage is a pulsating DC voltage. It is not a pure wave or a pure value or a constant value. It is a pulsating part, so we have to remove the pulses or the ripples present in this, and we use a filter circuit at this part. Normally a RC filter is used, resistor capacitor filter or a capacitor filter is used at this part to remove the ripples from the circuit so that we get the fluctuating part, so filtering part. Once this is done, then we use a regulator. So because the filter, it depends upon the components used in the filter, and there might be small variation in that filter, and because of it there might be variations in the voltage. To stabilize that, we use a regulator, and the final output will be a constant voltage, what we call it as a DC. And the main part from between the output and the filter is the regulator, which regulates the supply voltage if there are any changes in the load or changes in the AC supply. Now again, moving back to the stabilizer example, you might have noticed that when there are changes in the supply variations, but the stabilizer maintains a constant output voltage, either above a particular level or below a particular level. If there is a change, the voltage of the stabilizer is constant. It will not affect the electronic devices what we are going to use in it. So this is the block diagram of a regulated power supply. We call it as RPS, regulated power supply also. Then moving to the important part, power supply performance parameters. So while dealing with the regulated power supply, there are various performance parameters or factors what we have to consider into account so that the voltage remains a constant value. The output voltage remains a constant value. The first parameter is a load regulation, what we call. Now, what is this load regulation? The load regulation, or also we call it as a load effect, is the change in regulated output voltage when the load current changes from minimum, that is we call it as a no load, to the maximum value, full load value, minimum load to maximum load. So when there is a change in output voltage from this minimum load to maximum load, we call it as a load regulation, and we denote it as load regulation is equal to VNL minus VFL, where VNL refers to load voltage at no load. There we are not going to connect any load to the part. It is open circuit what we consider, and VFL refers to the load voltage at full load, where we connect a load across the supply. Also, the load regulation can be expressed in percentage, given as percentage load regulation will be equal to load regulation with respect to full load voltage. So VNL minus VFL divided by VFL into 100%. So this is about the load regulation, which is the first important parameter of a power supply circuit. Moving on to this next one, minimum load resistance. What is this minimum load resistance? The load resistance at which power supply delivers the full load rated current at a rated voltage is referred to as minimum load resistance. So the rated current will flow when load is minimum. So the load resistance at which power supply delivers full load rated current at rated voltage, and this is given as minimum load resistance is equal to VFL divided by IFL, where VFL is the full load rated voltage and IFL is the full load rated current. The next part is the source regulation or line regulation we call. That is from the input side what we considered when we use a rectifier circuit. The source regulation is defined as the change in regulated output voltage for a specified change of line voltage, Now, when there are changes in the AC supply, there might be changes in the output voltage also. That change is represented as source regulation or line regulation, where we denote it as SR, source regulation, which will be equal to VHL minus VLL, where VHL refers to the load voltage with high line voltage and VLL refers to load voltage with low line voltage. And this also can be expressed in percentage form as percentage source regulation will be equal to source regulation, that is VHL minus VLL divided by V nominal into 100. So V norm is nothing but a nominal AC voltage, what we consider. Next important parameter is the output impedance. A regulated power supply is a very stiff DC voltage source. Stiff DC voltage source means it has to maintain a constant output voltage. This means that output resistance is very small. Even though external load resistance is varied, almost no change is seen in the load voltage. Now, and we can say that ideal voltage source should have an output impedance of zero value, very small and zero value of output impedance for an ideal voltage source. And the next parameter is the ripple rejection. What is this ripple rejection? The ripple rejection is a factor which indicates how effectively the regulated circuit rejects the ripples and attenuates it from output to input. Ripple is nothing but it is a variation in the input voltages. So this factor indicates how effectively the regulator rejects the ripples and attenuates from input to the output side. And ripple rejection is given as ripple content in the output divided by ripple content in the input, which is equal to VR out divided by VR in. Normally this ripple rejection is considered in decibel, which will be nothing but ripple rejection in decibel will be equal to 20 log of ripple rejection, R what we call. So these are some of the parameters of the power supply, and these parameters or factors should be considered while a DC power supply has to be used.